The next thing I want to do is connect the top ends of the intersection splines. The spline I add also needs to lie directly on the revolved surface body. The tool I select for this job is the Spline on Surface tool. I select the revolved surface, initiate the Spline on Surface tool, which can be accessed from the menus at Tools, Sketch Entities, Spline on Surface, and draw a 3-point spline connecting the two intersection curves together. With the spline in place, I'll turn off Spline on Surface. Notice that each point of the spline has an on-surface sketch relation. To make a smooth transition, I'll assign an equal curvature relation between the splines. If the equal curvature relation causes the spline to go in the opposite direction than you expected, right-click on the relation in the Property Manager and select Flip Relation. Finally, I'll add a coincident relation between the internal control point and the temporary axis through the middle of the part. SolidWorks might report an error when this relation is added. To eliminate the error, delete the on-surface relation on the control point. To make sure that the sweep will work, I need to check the minimum radius of the spline. If the minimum radius is less than the size of the sweep profile, the sweep will be self-intersecting and will fail. The sweep profile I'll be using is a circle with a diameter of 0.4 inches or radius of 0.2 inches. As long as the minimum radius of the spline is greater than 0.2, the sweep should work fine. To find the minimum radius of the spline, right-click on the spline and select Show Minimum Radius. If the radius shown is near to or less than 0.2 inches, then I need to adjust the magnitude of the spline handle to increase the minimum radius to a value over 0.3 inches. Remember that if you change the magnitude of the interior spline control point, you should enable the Maintain Internal Continuity option to avoid abrupt changes in curvature through the point.